Hello everyone. In this video we will cover the factors affecting hydration enthalpies, how exothermic they can be or will be. As I've stated here, the magnitude of the enthalpy of hydration of ions depends on two factors, the charge of the ion, as well as its ionic radius, as stated over here. I've stated in video number 1 that these are the exact same factors that affect the magnitude of the lattice enthalpy, and it's the exact same or the exact same factors that affect the hydration enthalpies as well. I will first discuss the effect of charge. This should be of, the effect of charge, excuse me for a minute. Effect of charge. The higher the charge of the ions, the more exothermic the enthalpy change of hydration will be. This is due to the stronger electrostatic forces of attraction that will occur between the ions and the water molecules, basically between due to ion dipole interactions. The stronger the forces of attraction between the ions and the water molecules, the more stable the charge on the ion is, and thus the more energy is released, producing a more exothermic enthalpy change of hydration. When comparing two ions that have the same charge, I would consider its ionic radius. The effect of ionic radius is the same as we stated previously for lattice enthalpy. Smaller ions have more exothermic enthalpy changes of hydration. This is because the smaller the ion, the greater is its charge density, and thus the stronger is the electrostatic force of attraction between the ion and the water molecules, and thus the stronger these forces of attraction are, the more stable the ion is in solution, and thus more energy will be released, forming a more exothermic or producing a more exothermic enthalpy change of hydration. I have placed some examples here. As you can see, when comparing +1 ions with +2 ions, the higher the charge on the ions, as you can see for magnesium and calcium ions here, the higher the enthalpy change of hydration. The magnesium has negative 1920, calcium has negative 1650. When compared to ions that have +1 charge, they have much lower exothermic enthalpy changes of hydration. If we were to compare group 1 or group 2 ions, cation ions, as seen here, group 1, if we consider lithium, sodium, and potassium, they're all group 1, and they're arranged as you go down the group. As you can see, they all have the same charge, but as we go down the group, the ionic radius increases, and thus the charge density decreases. When the charge density of the ion decreases, the attraction or the electrostatic force of attraction between the ion and the water molecules decreases, forming a less stable ion in solution, which would produce a less exothermic enthalpy change of hydration, as seen here. As we move down group 1, lithium, sodium, potassium, they all have the same charge. But the ionic radius increases, and thus charge density decreases. This decreases the electrostatic force of attraction between the ions and the water molecules, forming a less exothermic enthalpy change of hydration. And this applies to group 2 as well. Calcium has a greater ionic radius than magnesium, because this is moving down the group as well, and thus the enthalpy change of hydration is less exothermic for the same reasons. When asked to compare or explain trends in enthalpy changes of hydration, as we discussed for lattice enthalpies, the magnitude of charge has a greater effect on the enthalpy change of hydration than does the size of the ions. Thus, the hydration enthalpies of all 2+ ions will always be more exothermic than those of 1+ ions, regardless of their ionic radius. This applies to negative anions as well. It's the exact same thing for anions. and thus they are the exact same factors for lattice enthalpy. If I were given two ions with the same charge, my answer would involve discussing the ionic radius or exploring the ionic radius of these ions. But if these ions had different charges, my answer would only involve discussing their charge. Please solve the attached worksheet. Attach the worksheet that for both videos. Please solve it and make sure to submit it by midnight tonight. Thank you for watching.